Have you ever noticed a crack in sidewalk or buildings? That's not just ugly, it's a big problem.
But what if the concrete could fix itself? Let's meet self-healing concrete.
So what exactly is self-healing concrete? Self-healing concrete is a mixture of concrete that is integrated with self-repairing agents. Looking back at its history, it was pioneered by Dr. Henk Jonkers, a microbiologist at Delft University in the Netherlands. Dr. Jonkers was inspired by bionics, specifically how the human uses osteoblast cells to repair bone damage. He recognized that the traditional infrastructures require billions of dollars in manual maintenance, which is often logistically impossible in deep underground or marine environments. This motivated him to fuse microbiology with material science, creating living concrete matrix where nature provides the repairs automatically.
When water gets into those tiny cracks, it reaches the metal bar inside, making them rust and weaken the structure. It's like a magic, but it's actually science. We add special material inside the mix. When a crack happens and water gets in, this material wake up and grow to seal the gap. This keeps water out, making our buildings and bridges last much longer without needing expensive and dangerous repairs. So it's smart, safer, and better for our planet. That is the future of construction. So now, let's move on to engineering properties and application for self-healing concrete. Think of the concrete in our tunnels and bridge. It is strong, but eventually it cracks. That's exactly what self-healing concrete does. It automatically seal cracks up 0.8 millimeters wide. This keeps out water, oxygen, and salt, which are the main enemies of concrete structures. This is a game changer for places like subway, tunnel, or marine docks, where manual repairs are dangerous and disruptive. It's not just a material, it is an asset to keep our infrastructure safer and stronger for much longer.
Moving on, let's see the core advantages of self-healing concrete. So firstly, enhance the durability.
Cracks accelerate the deterioration of concrete structures by allowing the ingress of water and harmful substances. Self-healing concrete addresses this issue by automatically sealing cracks, thereby enhancing durability and improving resistance to freeze-thaw damage and corrosion.
Secondly, increase the lifespan of structure.
Self-healing concrete enhances structural integrity by automatically repairing cracks over time, thereby minimizing potential damage and significantly extending the service life of the structure.
And thirdly, reduce the maintenance.
Traditional concrete accounts for 8% of global carbon emission because of its extended lifespan, the reduced volume of cement required, and fewer maintenance visits. Self-healing concrete generates a smaller carbon footprint.
Last but not least, reduce the maintenance costs.
Self-healing concrete minimizes the need for repair and routine maintenance by autonomously sealing cracks, thereby reducing the overall life cycle cost of the structure. So, how does self-healing concrete help make construction more sustainable?
To address how this makes construction more sustainable, let's look at the SDGs. First, it promotes innovation in construction under SDG 9 by introducing advanced self-repairing technology to the industry. Secondly, it improves long-term economic sustainability. Longer-lasting structures will reduce the deterioration, which directly improves public safety and infrastructure reliability. Thirdly, it supports climate action under SDG 13. It reduces structural failure risk in urban areas and lowers the high carbon footprint associated with maintaining roads and bridges. Lastly, it will contribute to sustainable cities and communities under SDG 11 by lowering resource consumption and optimizing the overall efficiency of construction practices.
Hi, my name is Nasha. Do you know every year the world spends billions to fix cracked roads, cracked buildings, or maybe a cracked bridge? But can we actually cut the maintenance costs maybe by half? So let me explain the innovative technology behind the self-healing concrete. Let's go! By giving concrete its own immune system, this technology introduces four game-changing innovative technology to modern engineering. First, it extends the lifespan of structure by automatically fixing the micro damage, allowing to buildings, roads, and bridges to last longer without needing expensive destruction. Secondly, do you remember what I told you about the maintenance cost, right? It will drastically reduce maintenance and repair costs by removing the constant financial burden of hiring manual repair crews to patch up the crack. The third one is it will improve structural durability because sealing the cracks keeps the water out. So it will prevent the internal steel reinforcement bar from rusting and falling. Finally, the last one, it supports a more sustainable future, which is aligning perfectly with SDG 9 because structure lasts longer, global demand for new cement drops, and significantly reduce carbon emission. That's all from me.
Hi, now I will evaluate about the impact, challenge, benefits of self-healing concrete towards society, construction industry, and the environment. Firstly, for society, self-healing concrete improves public safety by automatically repairing small cracks before they become serious structural problems. This extends the lifespan of buildings, bridges, and roads while reducing maintenance costs and minimizing destruction to the public. However, the main challenge is its higher initial cost. Secondly, for construction industry, self-healing concrete reduces repair work, lowers long-term maintenance costs, and increases the durability of structures. However, contractors face challenges such as higher initial costs, limited industry standards, and the needs for specialized knowledge during construction. Finally, for the environment, self-healing concrete helps reduce construction waste, lowers carbon emission by decreasing the need for frequent repairs, and conserve natural resources by extending the service life of structures. Although producing self-healing materials may require additional resource, engineering studies shows that the long-term environmental benefits outweigh the initial impact. Overall, engineering research and industry stakeholders believe that while self-healing concrete has higher upfront costs, its long-term benefits in improving safety, reducing maintenance, and supporting sustainable infrastructure make it a promising material for the future.
In conclusion, self-healing concrete represents a vital evolutionary step towards smarter, sustainable, and long-lasting cities. While commercial cost hurdles remains, its profound benefits to infrastructure's resilience and global climate goals make it a cornerstone of future engineering. Thank you very much.